computer screen. What? Okay, reset my computer. So still double check your graph right now. Check it with your friend. Make sure you're on the right track before I turn on my iPad. I don't know. Okay, it's working. Okay, which one you want me to graph? Number two, okay, so I don't know what's number two. Can somebody tell me what the number two is? Hold on, let me try to look for the thing. Uh, I don't know what's number two at. Oh, right here, I found it. There's a missing an X here. Number two is cosecant graph. Let's get start. The nice thing about... Did you do homework? No. Okay. Cohen, did you do homework? Cohen, how come? You were here.
Fell asleep as soon as I got home and just slept.
All right, so Michael, you did your homework, right? Okay, cool. Number two. I am gonna copy this and I'm gonna paste it here. And it doesn't take long time to figure out the information. By the first thing, I will always take out the -2 cosecant of 3/2 x minus, well, pi/2 divided by 3/2. So it'll be pi/2 times. So is that pi/3? Amplitude is gonna be, by the way, I wanna address something. The amplitude for sine is, so this amplitude for sine is gonna be absolute value -2 is equal to 2. Now I wanna address something. For cosecant and secant, actually technically, they don't have amplitude. But you need an amplitude for sine and cosine in order to graph cosecant. So right now I'm gonna put down as 2, but you gotta recognize cosecant. So you might want to write this down on a note. Cosecant and secant does not have amplitude because amplitude is a distance from the midline to the peak or trough. But the other way is actually it's opposite. So it's actually no amplitude for secant and cosecant. So I will probably write down no amplitude for secant and cosecant. Now I am gonna I'm gonna use this for now, but doesn't mean that there's amplitude. So period is gonna be 2 pi over 3/2. I don't know, 2 pi times 2/3. So 4 pi over 3. And the quarter period is gonna be pi over 3. And which is nice because yeah, same thing as a horizontal shift. So this is actually really nice. So a shift right pi over 3. Now remember, each increment you gotta make sure they are the same. So what I'm gonna do is I'm gonna say each 2 increment is pi over 3, but it's shifting left pi over 3. I think it's left or right? Right?
Yeah.
Right pi over 3. And the midline is 3, so midline is 3, so I'm gonna draw a midline here. And so technically, cosecant graph is related to which graph? Sine. So sine is start at midline going up or down. So midline is right here, so it start right here. So I feel like sine and cosecant are easier to graph than secant and cosecant, because cosecant and secant you have to know that it's at the peak or trough. But this one is always start at the midline. But the only thing you have to pay attention are they negative or positive. So they're negative, so it's going to go down. So each increment is 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, negative pi over 3. And you can use increment of 2 or 3, it doesn't really matter here, but as long as you keep the same. So you have to make sure you keep the same. So ideally is I'm going to graph the -2, so it's going to go down here. It's going to go down here, here. Some people say they cannot draw a straight line, draw a curve. Me neither can I, but I'll try my best. So I'm going to try like this, and I'm going to go like this, and like this, and that's one period. Like this, like this, like this, like this, like this. Now here's the hard part, is how do I create asymptote? The asymptote is when this part midline hits. So there was an asymptote here, 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 and there's an asymptote here. Now I'm going to graph in the graph. Technically, I don't want to erase the things, but I'm gonna let you show you what a graph is without a sine graph. So I'm gonna go back and erase all the sine graph. So I hear at this moment I'm okay with the graph like this because you just show me 2 graphs. But technically they can erase them, and that should look like end up to be like this. Does that make sense? And if you graph this point, you're doing great. Anybody have any particular questions before I go forward? I'd rather you understand now. I'd rather you ask me a question. This will be what's exactly going to be like on the test. Number 1, did you check on the decimals? Huh?
I don't know if I did that.
You gotta do it. Sometimes you have to check your graph. I'm gonna graph secant and cosecant, but I don't have time to keep on going graphing because I gotta go over one other question. I will usually answer, but I have to teach you how to graph tangent and cotangent graph. But I'd rather you make sure we understand one graph first. Emerson, do you know how to graph this?
Yeah, I
All right, okay. Anybody else have problem on this? This is what's gonna be on the test. Is this too difficult for you? No? Okay. Now, this part is a little bit more difficult. So, it turns out there's an infinite amount of answer. But the hardest part is to pick up your starting points. Obviously, your starting point, you have all those choices to choose from. This one, this one, this one, this one, this one, this one, and this one. Depending on which one you pick, everyone is different. Okay, so I'm gonna pick this one just because I like, it's closer to x-axis or x and y-axis and things like that. So first thing I will analyze is where the midline is. Where's the midline? -1, right? So we can go to here. We can say that's the graph happened and that's the major graph of the midline. So midline is, and this is a very important because you're gonna have a whole project on this. You're gonna have to figure out each individual part first. So if you have any question, let me know now. You can write it on today's notes. You can actually start to figure out midline. This one is what? -1, sorry. I like. Amplitude is what? Well, amplitude is not -3. Amplitude is always positive because that's the distance from midline to the peak or midline to the trough. It's absolute value, so it's 3. But I understand why you say -3 because if I were to pick this point and it's going down, your sine probably is going to go -3. Okay, so I'm going to say it's sine at pi/3. This A is probably equal to -3. Not the amplitude, but A is -3. So remember, you're going to either choose this. You already have a D. That is what? -1, right? You already have A. That's equal to 3. That's half the bottle right there. And you also have a C, actually, is actually here at pi/3. Because shift right pi/3. And shift right is at x minus that. Am I going too fast? Now I'm just going to figure out a B. And you say, wait, B, how do I figure that out?
Make out a whole period and use 2 pi divided by period.
Yeah, I mean, I possibly, but I'm just gonna pick a period by looking at the graph. I'm just gonna pick it the peak to peak or trough to trough. What do I mean by peak to peak? I'm gonna pick this specific point to this fixed point. That's called peak to peak. I know that's period, so I hear 7 pi/4, and I hear -pi/4. -pi/3, sorry, can't read. And I can do 7 pi/3 minus -pi/3. So the distance is 8 pi/3. Does that make sense? So I figure out what a period is. Very important because it's going to have a whole project on this. I'm going to give you a whole bunch of graph and you're going to have to go back and figure out each one. Like clockwork. So it's 8 pi/3. So you pick the peak and peak or trough and trough. So in this case, you can also pick those 2 points here. This is not peak to peak. This is just midline and skipping a midline. So that's also a period. So regardless, that's equal to 2 pi/b. So we're going to set it equal to the period because we're trying to find a value of b, and this is the goal. Now you can do cross multiply. So that's going to be 6 pi is equal to b times 8 pi. And the b is equal to 6 pi over 8 pi, which is roughly 3/4. And there it goes. Y equal to 3 sine -3, by the way, sine of 3/4 times x minus pi/3 minus 1. Does that make sense?
How do I know that it's -3 and not just 3?
That's a good question because sine graphs start at a midline, but since it's going down, that's going to be -3. Yes.
If we found B3 using the way we multiply.
What?
We were finding B3.
I would rather do it this way. Here's why I do it this way is I'm doing mathematically and solving something. It doesn't mean it's wrong, but there's just something I always prefer. I think that I try to teach like the most foundational way to thinking about it. The foundational way is just understand that the period is this, and now set it equal to 2 pi/b, which is the formula of periods. And if I evaluate it, that's gonna give me a right answer. It doesn't matter what. because sometimes a period is, let's say, it's 3/4. Then you're gonna say, oh yeah, 3/4 is equal to 2 pi over b, and then you got 3b equal to 8 pi, and b is equal to 8 pi over 3. And so this is a very just intuitive. It's not like you had to think about quarter period. I'm trying to break down the thinking that's easier for everybody can cross out, because you know the formula is 2 pi over b. All you gotta do is set the period equal to 2 pi over b and solve it. You learn also solving equations as well. So you learn multiple things while you're at it. Questions? Yes. A very good choice. So what if that's a great question. I love the questions. So how do I know it's sine and cosine? Because it's sine and cosine, it's gonna start at a midline. If I start at peak or trough, then I'm gonna be. So here's the thing. I say there's an infinite amount of solution. Can I choose this point to start with? Well, it chooses the same. So y equal to, well, you pick the trough, it's going to be -3. Is that okay? And cosine, period is not going to change, because just if you pick a different point, it's not going to change. And then that's going to be x minus pi rather than minus pi over 3, because you shift all the way to there, -1. I just figure out the second solutions using cosine, because on that project, I'm going to ask you to do is ask you to figure out the sine and cosine, both of them, and there are infinite amount of solutions. So I can pick this point here again. I can say y equal to, well, this case is going to be what? +3 or -3? +3 sine 3/4 x minus 5 pi over 3 -1. It's basically everything the same thing. I just have to change the a to +3, because I start at this point. It's a sine graph going up. Does that make sense? All right. All right, all right. You guys doing okay? Now let's go to tangent and cotangent graph. I have a lot of time. Tangent and cotangent graph, I feel like it's one of the hardest thing to do, but at the same time, a lot of time it's all like it's all about mental. Believe it or not, like if you're an athlete, right? Or if you are, and I was never a very good athlete, but I'm always try to be an athlete, but I try to think of in terms of athlete, even though I have no athletic ability at all. So it's like when I say something is hard, there's two type of people. One type of people is gonna be like, oh my god, it's hard. I can never do this. And second type of people says, okay, it's hard, then I'm gonna start by learning the basics. So it doesn't matter what I say. I can say it's hard or it's easy. The fortitude of psychology, if solving problem, or psychology of doing sports, or psychology doing anything, it's always gonna be like, it doesn't matter how hard it is, I should be able to do it. That's why smartest people, they not just because they are smart, it's because they have a very good confidence. I just talked to Amil about this yesterday. It's like, and he tried to go to MIT, and I says, well, if you really want to go MIT, you really have to have that ability to believe that anything other people can do, and you can do just as good or better. And that has nothing to do with talent. Okay, it's nothing to do with talent. It just have something that the chip in the shoulder says, anything that guy can do, I can do. But otherwise, you go to MIT, even luckily you got into MIT, you're gonna get destroyed. You're gonna get destroyed by those people. Okay, so it's never about your ability. It's about your confidence that you can do something. So when you go into let's just say go into competitions, right? I think I saw Austin playing water polo the other day, and Rebuff says like, you are one of the best kid besides you and Luke. You guys kind of carry the team. But when you go into face a harder team, like the best team, are you gonna feel like I'm gonna lose to them? No, yeah, you're gonna feel like I'm gonna do even though they rank higher, I'm gonna try my best. I'm gonna try to kick their ass. And the thing is like this. So same thing is about math as well. And I will say it doesn't matter how difficult it is. You can just say, okay, yeah, I can learn it. I think like the people really have that in my CalBC class, like Anthony, like Matthew Sheldon, like Matt and Boris. They all have the same type of mentality. It's not because they are smarter; they are smart, but it's also because their attitude toward things. Their attitude says, "Hey, I can do anything just as well." So what I wanted to do, even though it's kind of difficult, but it's because it's different in sine and cosine, but doesn't mean it's hard. When I say it's hard, it's like different. Okay, so I'm gonna show you how to graph tangent of x graph first. Now, the only thing difference about tangent of graph, they not wave. And the reason why they're not wave is I'm going to plug in some points. I'm going to show you why they are not wave. So x and y. I'm going to plug in negative pi over 2. What happened tangent of negative pi over 2? What is it? Is what? No, not -1. It's undefined. So negative pi over 2 is undefined. So it's asymptote. And at pi over 2, I'm going to put on the bottom here. It's also undefined. So that's the next asymptote. Is that okay? What happens if we plug in 0? 0. It looks like I graph 2 asymptote and I graph middle. And I'm going to pick a middle point here that just says negative pi over 4. What happened tangent negative pi over 4? What?
1.
No. -1. What happened if you plug in pi over 4? 1. So it's going to be like something like this. Okay, let's just plug in, let's say let's plug in very close to pi over 2. Which value that you thinking close to pi over 2? Maybe pi over 3? Okay, so am I gonna do pi over 3 here? What happens if you plug in pi over 3? What's tangent of pi over 3? Do you guys recall? What's tangent of pi over 3? Okay, so you guys need to know basic things. So draw this. It's to help you to find exact value. So here's one of the things I want you to draw it out. If it's something like this, it's a 45 degrees. So tangent of pi over 4 is always equal to 1. Any tangent of pi over 4 is always equal to 1. So knowing that value. And knowing this value here, anything tangent of pi over 6, always root 3 over 3. And another value here, any tangent of pi over 3 is always square root 3. So if you know this value, all we gotta know are they over pi over 4 or pi over 6. Anytime pi over 6 is going to be square root 3 over 3. Anytime you have over pi over 3, it's always square root 3. So square root 3 is right here. And negative pi over 3 is going to be negative square root 3. Now square root 3 is roughly 1.7, roughly 1.7. So square root 3 is 1/3 here, so it's going to be somewhere here. So 1.7 is going to be something like this. And at negative pi over 3, it's going to be something like 1.7, something like this. So it turns out I only need a red points, but the more closer you get to pi over 2, that means, let's just say if I pick a value that's closer to pi over 2, the more closer I get to pi over 2, the more higher the y value, but also the lower the x value. So that means it's going to actually create an infinity situation. So it's going to actually go in like this. Oops, my bad. So it's going to be like this. Okay, so it's gonna be like this, and it's gonna be infinite amount the graph like this, because it's gonna be like something like this, and there's another asymptote, but it's gonna be infinite. But it's like start at 0, and you push your arm out as much as you can, and that's your asymptote. And it's gonna be like this, so that's the tangent graph. Now, what's the specific about tangent? No, let's talk about it. Is sine graph is an even function or odd function? Let's review. Sine graph is an even function or is that even or odd? Odd functions? Actually, we just learned that in Calculus C right now. We're actually using something called power series. And by knowing that's odd function is very helpful. Y equal to cosine x, is that even or odd? Even, because they are symmetry to y-axis. Is that okay? Now, only one more thing is y equal to tangent. Are they even or odd? By looking at the graph, what are they even or odd? They are odd. Thank you. But not only that, you can say, okay, well, it's from here to here. Now, what else I need to know about tangent graph? Really important. The period for the tangent graph is gonna be very important. Instead of 2 pi over b, here it's gonna be only pi over b. Only pi over b. That's it, pi over b. So instead of tangent and cotangent, so this is for tangent of x and cotangent of x. If you have period, it's always pi over b. So very important stuff for tangent and cotangent. When you graph, you're going to base on the period, and period is from asymptote to asymptote. Is that okay? Is that all right? Okay, so I'm just going to graph an easy one. So, matter of fact, I'm going to go to cotangent first. So, cotangent graph. Where do you think cotangent has asymptote at? What do you think cotangent has asymptote at? So 0 is undefined. Where else? Y pi. Okay, so it's 1 divided by 0. So, okay, that's fine. I can live with that explanation. So I'm going to draw the asymptote at 0. And I'm going to draw asymptote at pi. Actually, I'm going to draw another asymptote at 2 pi. So we're going to see all the things here. At negative pi. Okay, so the asymptote is right here. Now, you know, in middle asymptote is going to be in the midline. The line is going to be right here. Now, this one is going to be pi over 2, right? Because cotangent of pi over 2 is at 0. Is that okay? What happened with cotangent of pi over 4? What happened to cotangent of pi over 4? Cotangent of pi over 4 and tangent of pi over 4 are similar, right? Or are same, actually. So it's at 1. So we're going to say this is a 1 here. And this is a 2. And this is a negative 1. This is a negative 2. So it's actually like this. And it's like this, so the graph's going to be like this. Just like a tangent graph, but it's the other way. And there goes tangent graph, or cotangent graph. Now again, I figure out where the undefined is first. But usually they cotangent start at 0 unless there's a shift. So what's in the things you need to know for period for tangent and cotangent? Is what? Pi over b. So you have to know that. So you know at h pi is going to have another asymptote. At h pi is going to have another asymptote. Now in middle two asymptote is going to be in midline, and the other way it's going to go the other way. Cotangent is going to be this way. Tangent is going to be this way. So let's try to graph one. So let's just say y equal to 2. I'm going to take 2. That's yes. It's actually domain is gonna be all real number except the x equal to n pi. In this case, because when x equal to n pi, it's gonna be asymptote. Or you can find out what the asymptote is. It'll be x equal to n pi because if every pi, n is a natural number, so it could be 1, 2, 3, 4, 5. So it could be all the asymptote. Okay, Astra, yes. Okay, so when the cotangent, when do they equal to 0? Or when do they equal to undefined? Well, cotangent at 0 is undefined, and at pi is undefined. If you realize if I ask you cotangent of value 0 and cotangent of pi, that's what undefined. Tangent is going to be at negative pi over 2 and positive pi over 2. Those are things that I will kind of just know it by heart because I know what my starting point is. Okay, so now I'm going to graph this one. So it's tangent of, I don't know, 2x minus 1, something like that. Okay. Then I'm going to say, okay, well, this is just 2x. Well, can I take out 2? Of course. And that's my b, right? Okay, so sorry, that's not b. This is 1. So if I take out 2, so I can say, well, I don't have ember 2 here. Ember 2 is none. However, there's a stretch value of 2. What does that mean? That means your 1 or next value is going to go 2. Rather than go to 1, it's going to be going to 2. Okay, so where's my asymptote located at? Well, let's figure out period. What's my period? Pi over 2. Be careful. It's pi over 2 this time. Okay, you can figure out quarter period as well because each quarter period is going to have one major change. Either they're going to go stretch, midline, or stretch or asymptote. So it really depends on what it is. So in this case, it's going to be pi over 8. Yes. A is none. There's no ember 2, but there was a stretch value of 2 though. There was a stretch value of 2. I'm going to talk about that. So I'm going to go ahead and graph the midline first, like all the time. I'm going to graph the midline here. The midline is going to be something like here, -1. Is that okay? So the period is pi over 2. So what do you think the asymptote happen? So I will say at here is actually pi over 4 and a pi over 4. Why is that pi over 4 and pi over 4? Do you see why it's pi over 4 and pi over 4? What's pi over 4 plus pi over 4? Ian? You're not paying attention. Anything I say, just last 10 minutes. So what's the asymptote is going to be? The asymptote is going to be at negative pi over 4 and pi over 4. Do you see why? Because your period is pi over 2, right? So you're going to have to stretch both way, pi over 4 and pi over 4. That's going to give you pi over 2. So that's going to give you asymptote here. And that's going to give you asymptote. So I'm just going to graph one period here.
I think I missed it when you explained it, but why is there no amplitude?
Because the tangent and cotangent and secant and cosecant, they are just no amplitude. Amplitude is from midline to the peak, and midline to the trough. There's no peak or trough in the situations. Because, okay, just think about it. Period is pi over 2, right? Now you start at center. This is you. I'm going to go to the one side pi over 4, one side to pi over 4. That's in order to get pi over 2. Yes.
For the period, wouldn't it be just pi? Oh, I'm sorry. I forgot that it was pi.
Not yeah, it's not pi, not 2 pi over b, but it's pi over b for tangent. So I here's pi over 2. So if you think about pi over 2, if I start a center, right, then this side is gonna have to be pi over 4, and this side is gonna be pi over 4 because that's where the asymptote is. So if I stretch out, I figure out where's my asymptotes first. So if I figure out my head, I go into stretch both way, and that's my periods. Yes.
We just divide the period by 2.
No, because you're gonna have to still using quarter period because there was a quarter period here happen. So I hear pi over 8, which is I hear it's gonna be negative pi over 8 and pi over 8. It's gonna give you your next value. So I hear it's gonna start at -1, but this is gonna be 2 units above lat. So it's gonna be right here and 2 units below. And the graph's gonna be something like this. So it still happened 5 things and 5 points this quarter period. So, but you start off figure out, okay, where's tangent? Tangent in the middle is always at 0. Now, if you stretch both way, if you stretch a period for half the period on one side and half period on the other side. Is that okay? It's harder to graph tangent and cotangent because cotangent is much more intuitive because you start at a 0 as an asymptote. But in this case, you start at 0 as your center, and you stretch both ways. You stretch half period each side to get to your whole periods. And then you can say that's my asymptote, and this is my asymptote.
So just half of the regular period.
Yeah, it's stretching from your body, your center, because this is your body, right? This just imagine this is my center. I can stretch as much as I can on a half period here and a half period here. So I'm going this way so I can see my whole graph. Once you graph the asymptote, you know how to graph it. It's in the center. It's going to be like a squiggle line. But it just have to meet at the center here. So I'm going to try the cotangent graph here. So cotangent of x, let's say if I have y equal to 3 cotangent 3x. Actually, let's not do 3x. Let's do half x plus 4. So if you have this part, then cotangent yin, you gotta pay attention. So cotangent start where does the asymptote in cotangent? It start at 0, right? So that's pretty easy. It start at 0. The asymptotes always start at 0. There's no shifting. So, and if you're shifting, it's just based on shifting. So there's an asymptote at 0. Is that okay? Because cotangent start with the asymptote. Now I'm gonna go into says pi over 1/2. So amplitude is none. Period is equal to pi divided by 1/2. What is pi divided by 1/2? 2 pi. So that means in next 2 pi here. So in the 2 pi here, it's going to be right here. 2 pi is going to be your asymptote, your next asymptote. At 4 pi, it's going to be your next asymptote. Is that okay? So once you graph the asymptote, everything else is easy. Because at the center asymptote, there was a 4 unit here. So 4 unit here, because this is the midline. 4 unit above, it has a vertical stretch. Now it's gonna have this 3 units above and 3 units underneath, and that's gonna be a graph like this. And 3 units and 3 units here, the graph's gonna be like this. Now today's graph, make sure you just try it as much as you can. Tomorrow we should be able to understand a little bit more. Look, I'm not gonna deposit your check because you help me carry the ping pong table and stuff like that. I mean, you're my student. I'm gonna
You have
help.
to deposit the check to the person you gotta give it to.
Why? Because I feel like if I deposit check, I had to buy you donuts, and I don't feel like buying you donuts.
Okay. Still gotta deposit the check. I'd rather you feel guilty.
No, I don't want to feel guilty. I don't feel guilty. I help you increase. It doesn't matter if I did or not. It's probably in class. It's more like in a calculus class rather than It's probably more like in calculus class than actual like those two sections that we met each other. It's put on my table and I stare at it. I was like if today you didn't give me money, I will want you to give me money. But today you give me money, I just like I actually don't want your money.
That's good. Your money. And you not putting that check in is the same thing as you giving me back all that money.
Yeah.
I don't want your money back.
How about this? I'll pay you for ping pong lesson.
Alright, I'm not the best at ping pong, but
But you can always I just pay you to whoop my ass so I can get
yeah,
better.
I'll hit
Because I really don't think I think I help you, but it's not in the session. I think I help you is like very precise on your calculus work. Hey, why you have two book bag?
Oh, after school stuff.
Oh, you work? That's your work stuff?
I'll see. For the homework, for book homework, I have one of the books in my house. Do you want it in point slope form or something else?
Point slope is easier.
I did it with this on.
Want to see my work?
Yes, I need to see your work. See everybody work. And Luke did not finish either. Yesterday, it's the test. The test you're supposed to go over it.
Oh yeah, no.
Did you finish it?
I think I did all of them. except for the
Let me
last
see where I started.
Why your work so messy? Andy?
So this is question 1, 2.
Put a damn parenthesis! Put a damn parenthesis!
Where?
Look, if you don't put a parenthesis, this is multiplied by this. But it's actually the whole thing multiplied by this. So you need a parenthesis right here. If you don't have parenthesis, that's a wrong answer. Look at it. Look at over there. The parentheses over there. The answer is over there. You gotta check your answer.
Okay.
So none of this are correct. You're just missing something. You're missing a y on this side. You didn't check your answer.
No, I multiplied.
No, I'm not looking at
No,
that
I'm
until
multi-
you fix all
No,
your shit.
this is not
Until
my.
you
the
fix all
answer-
your
The
shit.
answer is right here.
No, until
this
you
is-
fix all your
This
shit.
is not my answer. This is my answer. I
You
multiplied.
still didn't put a parenthesis.
I did it right there. Oh, over here.
If I had two guns, I'll be like this.
Oh my god.
But the work was put in. Like
It's not right. The work you put in is not right. You didn't check your answer. Does your answer is posted on the group chat?
okay, I'll do it.
Ugh. If I have two guns, I will shoot against myself. And the bullet's gonna explode right in the middle. Why? Tomorrow is Friday? Tomorrow we're just gonna go over today's work and make sure you understand all the integrations. You have a lot of busy schedule. I don't know how you do the schedule. Yeah, water polo pretty much every day. Oh, okay.
In the mornings, I usually just do whatever I can. The issue is because I have like a 2-hour period, right? Like at 6, 7, or before water polo, where I do my somewhat doesn't close until 6:30 at night. The homework.
I posted yesterday at not 6:30.
It'll be.
Lyndon, what's up with the purple?
Purple shirt.
All right. Did you do your homework? Which one's hard?
Like, German harder, Mr. A.
Okay, I think yesterday I was doing one question and I saw some people. I see Adam was doing that one question. I didn't make mistake by accident, so I want to see if you did it right. Maybe you did better than I did. Yeah. What was it? Tangent inverse of 1 over x. Take a derivative of this. What'd you guys get? I don't know which questions.
I got negative x to negative 2 over 1 plus x to negative.
I got -1.
-1 over x squared plus 1. I think that's the right answer.
Oh, man.
What are you using LN? Lyndon, what kind of crack you been smoking? So how do your dad do, Kevin? How do your dad do?
Not good. You got a 4 out of 19.
So you did better than your dad?
Yeah, but he also hasn't. He doesn't. He's not. He's like, Kevin, I can't take the test. I don't remember like half the formulas. Like he doesn't remember all of the integrals of like.
The picture of he actually trying is pretty funny.
Yeah.
I showed to my wife. I was like, I explained to my wife what happened. I was like, wow.
He said he thinks he at least would have got like a 60 if he knew his formulas. Integrals and derivatives. Like during the test, he's like.
The funny though, he put more effort than some of the students did.
What does it do?
He actually is like he challenges Kevin, says I can do way better than you one-on-one on this test. So he actually go in and do the whole test.
Oh my god. What does it do for? What does it do for?
He's at He's like, Kevin, I forgot integral of secant.
If an engineer could do this test, maybe we could give us some bonus points. Oh.
Yeah, that's weak. That's weak. Okay, so I think I did this one wrong yesterday because I forgot to take the u prime. But you're supposed to take this is u, so the u prime is gonna be -1 over x squared over 1 plus 1 over x squared. Did you guys do that?
Yeah.
And there were so many mistakes that happened. So Adam and Corbin and Dings, oh, even myself, I forgot to take a derivative on the top. So anyway, so this one's gonna be -1 over x squared. Algebraically, it's gonna be 1 plus 1 over x squared. So you're gonna multiply this side by x squared over x squared. So that is gonna be -1 over x squared plus 1 over x squared. And then -1 over x squared times x squared over x squared plus 1. So this will cancel out. That's -1 over x squared plus 1. So yeah, please don't break math, Adam. And that's okay because I happen to see it. Yes?
I had something really goofy. I split them up, and before I multiplied by x squared over x squared. That you can't do that, can you?
You're gonna have to show me the way.
Like you know how to do like I did 1 over x squared over 1 and then 1 over x squared over 1 over x squared.
For sure not, because what are you saying is this? What are you saying is like this, 2 plus 3 like this? And you know the answer is 5 over 2, right? So 2 over 2 plus 3 is 5 over 2, right? So what you did is you do this. Is that 5 over 2? So you just break math completely. Now, what you can do if it's something like this, just always think something very simple, see if you can do it, and try the numbers, see if it makes sense. Like when I was little, I usually try it because I want to make sure I did it right. And I want to make sure I don't break any mathematical rule, so I pretend there's a number in the same situation. So in this case, if I do this, right, that is bad because that's 1/2, but the answer is actually 1 over 3. But you know 1 plus 1/2 is not 1 over 3.
Yeah.
So I know I cannot cancel the 2, or I cannot split. So what I can do though is factor. Like this. Now you see that this is gonna cancel out as 1/3. If I cancel out as a factor, then I can cancel the factor. But I cannot split this way. Now 2 plus 4/2, you can split that way because that's gonna be 2/2 plus 4/2, and which is 1 plus 2, which is equal to 6/2, which is 3. So mathematically, if you ever want to double check if your mathematical concept idea is right, you can use a random number and just use in same situation. And then you should be able to discover that what you're doing is wrong. And that's why exactly when I see Adam did, and he did something similar like you, it's that I don't know how he got N, he got an X. And I'm like, no, that's wrong. There cannot be no way that's gonna give you X. So I don't know what he did, but he'd break up so many math there. So I say let's redo this again. That's fine. It's at least I discovered this mistake. Okay, any other question you want me to go over? Yes.
Can you go with number 10?
Can you help me?
Mr. Yeah, can you help me?
Anthony, can you help me? All right, so 10. What is question 10?
Inverse cosecant.
Inverse cosecant. Okay.
Parentheses x plus 1 to the power of 6.
Oh, wait, hold on. Like this?
Yeah.
No, whole thing's 5.6.
Oh, yeah. So the argument is 6.
Is it x squared plus squared?
X squared plus 1.
X squared plus 1? Okay. Landon, did you use natural log on any of those questions? Then why do you tell somebody that there's a natural log? Huh? Okay, first of all, there's chain rule. Okay, so 6, right? Times CSC inverse of x squared plus 1.
X squared.
Is x squared plus 1, right? To the fifth power. Oh, yeah, thank you. Yeah. I forgot 2. Thank you. So now what's the derivative of the cosecant? I think cosecant is negative u prime over absolute value u squared minus 1, right? So what is u in this case?
X squared plus 1.
So du is gonna be what? 2x negative 2x
Yeah.
over absolute value x squared plus 1. It turns out you don't need absolute value. Why you don't need absolute value? Because x squared plus 1 is always what?
Positive.
So it doesn't need anymore, right? And then it's gonna be x squared plus 1 squared minus 1. Not much I can cancel. I mean, probably the other thing, but I'll just keep it like that. There's nothing you can set. Because absolute value of this is always positive. But there's no need to put an absolute value positive if you got x squared plus 1. Like same things e to the 2x. And yesterday Sydney. So one thing I kind of like what Sydney did is I told her a story about a Martin. Like he would never leave the classroom without any misunderstanding. He will always come into after class and come to me. So she was asking, why is that e to the 2x yesterday was always positive? Because e to the 2x is a graph like this. Or e to the 2x or e to the x, the graph is like this. It's never negative. So that is not part of the problem. Same thing as x squared plus 1. X squared plus 1 is graph is going to be like this. It's always positive because it's x squared shift up 1. That's always positive. Eli, can you see over there? If you cannot see, move forward. Other questions? 63. Okay, I like the equation tangent line question. So what can you tell me what 63 is? It's not from 1 to 2 pi, it's a coordinate. That's 1 and that's 2 pi. and this is the x, and this is y. Now I'm gonna address a couple things. A lot of you guys do homework, did not check your answer, which is that's something I'm kind of frustrated about. And yeah, so I'm gonna talk about that in a second. So let's take a derivative of this. After take a derivative, what kind of rule are we thinking of? Particle. So before, right? Cosine inverse of x minus 1 plus, right? 4x, and this is a u, so it'd be negative 1 over square root 1 minus x minus 1 square. Did I do anything wrong?
No, you're good. So.
Okay.
How's it? Not hard.
Because 4x here is a function. Arc cosine of x minus 1 is a function.
Oh,
You did not do a quadratic rule?
not for this one.
No, you got to, because you got to see that's a product rule. Like I said, the most of you guys have struggling is you cannot see the parentheses. Either you cannot see move to the front. You can come back to ask Sophia for help later. Because I can see you, like, you have no idea what I write down. Is that okay? Did you do that? Did you do product rule, Ely? No?
Oh, no, I
You did or you didn't?
no, I
Okay, good. So now I'm gonna plug in 1 because I don't need to worry about simplification because my whole idea is to find slope. Is that okay? So I'm gonna say y prime of 1. That means 4 cosine inverse of 0 plus 4 times 0, which is nice. I don't really care about what happened here because the whole thing is equal to 0, right? And what's a 4 cosine of 0? What's cosine inverse of 0? It's a pi over 2?
I think so, yeah.
It's true.
Yeah, okay, pi over 2. 4 times pi over 2. And that's equal to what? 2 pi, right?
2 pi.
So it'll be y minus 2 pi equal to 2 pi times x minus 1.
Mr. Nick, why'd you do 4 times 0? Just the plus, like if you have 4x, why'd you plug in a 0? Instead of 1? You know what I'm saying? Like that entire thing you said is equal to 0, but you had the 4.
Oh, 4 times, oh, this is negative 1, right?
No,
Wait,
no, the one up next to it, you had 4 times 0, like the plus 4 times 0. Where'd you get the 0? Shouldn't you be plus 1?
oh, I plug in 1? Oh, shoot. I'm so sorry. Let's go back and redo this part. This is a 1. I thought it was 0 for some reason. My brain is not working. 1 minus 1. And this is, if I plug in 1, that's 0. Okay, I don't know why one side I plug in 0, one side I plug in 1. So this one's a 4. Cosine of 0 is going to be pi over 2. And a plus 4 times negative 1 over
Root 1.
square root 1, right?
Yeah.
So it'd be 2 pi. Is that okay?
Yeah, minus 4, right?
Minus 4. Okay, thank you. So y minus 2 pi is equal to 2 pi minus 4 times x minus 1. And this is probably the process you need to go through, but this is not the most important part. The most important part is you got to check your answer, see if your answer is correct. So if I did check my answer on the last one, I would have got completely wrong. But this one, hopefully I'll get it right. So I'll be say 4x. So you should check your answer on decimals, and you should be able to see the equation tension line. So arc 4x times arc cosine I don't know if you can work with our cosine. To the what? X minus 1? Okay, so it's gonna be this wheel graph, right? And then what is our equation tangent line? Y minus what?
Y1.
2 pi.
2 pi
Is equal.
Equal
2 pi
to?
minus 4.
2 pi minus 4 times x minus 1. And this is okay. See, this is the equation tangent line. First of all, you learn to practice what's equation tangent line look like. Second, you also check your answer, see, oh yeah, do they have equation tangent line on that specific point? And we did that, and they only intersect 1 point. Sometimes you can intersect 2 points. It really depends on where the situation is. So, so let's just say graph it has like this. Sometimes you can intersect at the end, but in that specific region, only intersect once, and that's what the equation tangent line look like. Any questions?
Wait, so then what is like the coordinates represent? Like how
The
far-
coordinate is this point right here. 1 and 2 pi. 2 pi is 6.28. The 1 and 2a. So this very good question here. So that's the things that you can get better. Is a specific point on this graph is gonna be 1 and 6.28. Right here, somewhere around here. And then you're gonna have equation tangent line. So that coordinate is gonna, so that's why I told you guys have to check your answer to
Oh.
decimals. So in that particular coordinate has some type of slope, and that slope is going to be the tangent slope at that particular point. Does that make sense?
Yeah, that makes sense. And it's the same. Yeah, it's the same coordinates as the original.
Yeah, that's a coordinate for the original function f of x, but you need to find slope at that in order to do a tangent line. So that's why you need to take a derivative to find the slope. And slope is 2 pi minus 4, and then you can plug in. Any other question? I'll go with one more. Light work? Okay, integrations. Integration is not much harder. It's just, there's sometimes this trick around things, so. I have big admiration of Kevin's dad. Like, he tried to make you better too. He has a good intent. I'm like a huge respect of him.
He's like, I did all these steps right. Like he's like, it might not be the way you do it, but I know I did all these steps right. He's like, show your teacher right now. I'll put money on it.
I think we will head it out, become best friends. Because I'm the same exact way too. Like my son bring back a homework from like Math Nation. I'm like, what the hell is this? This is wrong. And then like I'll write an email to the teacher says you teach it wrong. Huh? And the teacher says, no, you're wrong. I say, what did you just say? It was pretty funny. No, the OSS teacher was horrible. Okay, so what we're gonna do is, sorry, this is the example question. I'm just gonna give you a thing. So integration of, now this one is gonna be du over square root of a squared minus u squared. Now this one, it looks like what? What looks look like derivative of something? What is it? Yeah, sine inverse. So the integration of this particular format is gonna be arc sine of u over a plus c. What?
That's a 9.
It's a u.
So what's next to the U?
It's like
Sine of u over a.
U over a, yeah.
Oh.
Sorry, is that better? gonna rewrite all the U and A. So yeah, you're right. It's very confusing. And the integration. So now I give you a formula. You should know how to apply it. But for me, like I don't want to take a chance. So I rather go through all of them. And but this one's a little bit interesting. There's a 1 over a in the front. Arc 10 of u over a plus c. And I don't know. I actually like one of the things that always puzzled me is I didn't actually go look it up. Why does 1 over a in the front and arcsine doesn't have 1 over a in the front? Everything else has 1 over a in the front, and I didn't bother to look it up, but it'll be an interesting topic. You can look it up why that is. U times u squared, it doesn't need absolute value there, is equal to 1 over a arc secant of absolute value u over a plus c. Now, for me, again, I'm gonna say you don't need to remember the arc secant because it's never show up in exam and never gonna show up on my exam. It doesn't mean that's not important. It just more often in time that we usually don't use it. So only the first two, like if I were to make index card, I only make index card for arcsine and arctan. I don't really do arc secant. However, I'm going to show you a couple questions that's going to have like that, but I don't want you to memorize this for AP exam because you got a lot of things to memorize. And this is just not one of the things that will ever show up on exam. So no, I won't ask you to memorize that. And I won't even ask you on a test for that particular part because those are the things that's very hard to use all the time. So I want you to take an integration of dx over 4 minus x squared. Now, it's not a bad, it's very easy, one step. Now the next question I'm gonna have to go over with you, and I'm gonna tell you like what kind of things people make mistakes. So which formula does that look like? The first one, the second one, or the third one? First one, good. And this just only take 10 seconds to do. So what would be the integration of this one? Arcsine of what? X over 2 plus c. Yeah, this looks great, right? Yeah, easy, but be careful. Be careful. I'm just gonna say be careful right now. Okay? So especially this one. And I'm gonna say be careful. I'm gonna say I don't think anybody will get it right. I don't think anybody will get it right. Yep. So something I actually did, I'm going to show you what I did. As a squared equal to 4, a is equal to 2. U squared equal to x squared, u is equal to x. And there's a du equal to dx. Huh? Yeah, dx over 2 plus 9x squared. I'm going to say nobody will get this question right. I challenge you. I don't need you to rationalize. So rationalize is a lie that we made for you. Because technically 1 over root 2 is just as good answer as root 2 over 2. But we lied to you so because we can have a uniform answer. So it's always root 2 over 2. So, and we lied to student that you have to do it that way just because answer can be uniform. Imagine that some people put 1 over root 2 and root 2 over 2. It'd be easy, it'd be hard for grading because I have to look at 2 answer keys. But technically a number is a number, so 2 over 4 is the same as 1 over 2. Yeah. But we have to lie to you though. That's because we don't want to grade like two different sets of key.
Then you have to.
Huh?
You have to.
Unfortunately, AP is in multiple choice. All the answers rationalized, but it's FRQ. It didn't rationalize. They're not gonna penalty you. But so it really depends, right? Multiple choice is gonna be one set of answers, and you have to formulate your answer to that one set of answers. And it's much better to have a rationalized. Pretty much is for grading purpose because in the old textbook, in the older textbook, algebra textbook, they will give you some expressions as rationalize the numerator. So you have to rationalize the numerator. And there's the other set of questions as rationalize the denominator. And there's a last set of questions as just only yeah. So there's two sets of questions. There's one set of questions as rationalize numerator, rationalize denominator. Now, if you go to math competition, sometimes you have to rationalize numerator to get an answer. Sometimes you have to rationalize denominator to get an answer. So it's really not anything. I don't think anybody got it right. So does anybody challenge me to say if they got the right answer? Yes, Alvin?
1 over root 2 arctangent, arctan of 3x over root 2 plus c.
Nope. Yes.
1 over root 2 arctangent root 18x over 2 plus c.
How'd you get 18x? That's crazy. That's wild. That's wild. Okay. Okay, that's wrong again. So nobody got it right so far. Anybody want to give a shot?
No, it's because I rationalized it. I guess
So why did people get it wrong? Nathan, you always very confident. I try waiting for your wrong answer so I can make fun of you.
Okay. What?
It's just gonna give up.
Not. That's weak. That's weak, David.
We know, Mr. You said not to blurt out answers if you know how to.
That's good. See, you're learning. You're learning. That's good. I like that. Sophia, did you get an answer? Good. Thinking is good.
There's no way actually.
Okay, so it turns out like I would have got it wrong too if I was your age. If I was in the class and I would just have to be the first person that brought out answer and I would have got it wrong. And it's pretty normal. So let's talk about this a little bit, right? So do you realize the green things I did here is actually the clue of this? A squared is equal to what? No. What'd you get for? 2. A is equal to root 2, right? U squared is equal to 9x squared, right? What is U? Huh? 3x. Now, do you forget this? Like, how many times that you forgot to do du? Du, right? So du dx du over 3 equal to dx. Do you see that? So that's gonna be what? Du over 3, and this is a square plus u square, and that's gonna be what? Arc 10 of well, first of all, it's gonna be 1 over a. So 1 over root 2, right? Arc10 of what? Arc10 of what? 3x over root 2 plus c. And then there is a 1 over 3 in the front. So 1 over 3 root 2, arc10, 3x over root 2 plus c. I did same thing. I did a squared equal to 4, a is equal to 2. U squared equal to x squared, u equal to x. Du equal to dx. This case, du is equal to dx. That last case, this case, du is actually, du is actually 3dx. What? You got it? Yeah. So there was the small things that usually people don't pay attention. And if you and like I said, if I were a student in the classroom, I will not be smart enough to get it. Now there was probably a handful of students in the past actually got it, and so they just be paying attention to details. But if you realize in calculus is very detail oriented, the algebra is very detailed. Um, so you have to understand that there is detail happen. So therefore, it's 1 over 3 root 2 arc10 of 3x over root 2. The only thing, the difference between Alvin's answer and my answer is that 3 over there on denominator, but it's due to the du. A lot of people don't do this step on the exam, which is kind of frustrates me, because not only you have to do that in your work, you should do that in your head as well, and to anticipate if anything can cancel. So those are the things I think you guys need to get better. Yeah.
What's your parentheses?
What is this?
Up.
I don't need a parenthesis. Like, what do I need a parenthesis for? Tell me.
That's saying the 1/3 is multiplied to the 1 over root 2. So are we multiplying 1/3 to the whole thing? My apologies. I want to apologize.
No, it's okay. It's okay. It's good that you guys got to thinking about parentheses, and it's fine. I have no problem. Like, I think before you guys don't think enough. So that is that's a thing. So I'd rather you think a little bit more than think less. So this one is gonna be different format. So yeah. So let's see if you not make a mistake this time. This is also like very important visualization to see if things happen. To do du this time. Do you see why that du impact the answers? Sometimes people just gotta see those things. Unfortunately, that we all gonna learn from mistake. I told somebody in second, third period, and fourth period, I said ping is good. Sometimes you mess up a question, you understand that you mess up, and then it's good. Uh, du. I got du over 2, and what was the question here? I can du over 2, so this one is gonna be u and u square minus a squared, right? So what kind of format is that? Secant. So is I'm gonna go back and look at formula. Like I said, I don't remember this formula. So 1 over 3 arc secant of what? 2x over 3 plus c. Yep, that's the answer. So this 2x. So how much time I have?
You have 14 minutes.
Oh yeah.
1 over 6.
Yeah,
I
du.
thought you went over 6. Because
du,
you're
du.
for you 2x.
I got 1 over 3.
You get 1 over 3 from your 1 over a, but you forgot because you have d over 2. You have 1/2, no? You have 1/2 now.
Yeah, but this just make this is u. Because no, I changed du over 2, right? So then I can have 2x there because that's u and u squared.
Wait, I thought whenever we did like du and then you like if it was like you have like 1 over 2 or something, you just take it outside the integral.
You can take it out something, but you actually need this 2 there today. Because if u squared equal to 4x squared, right? Then u must be 2x. So you need that 2x there.
Okay. So then
To change this, so this 2x is changed to u. So you can have du over u squared root u squared minus a squared.
Oh, it's because the two, even the two is one because.
Yeah, I usually will take out 2, right? But the problem is I need that 2x there because I need that place to hold in place is u. So I just leave it there so I can use as u.
you still
What are you doing?
du like over 1/2 you just
So remember, I like even though like this step is not completely right because I have some du
yeah.
and some this, but I just want to show you that this 2x is there because we got du over 2. This 2 is going to be right there. So that is becomes u. If I just have x, then no, I don't have a u because u is equal to 2x.
Okay. Okay, so then you okay.
That makes sense. Because I did this G, I did back stuff. And then you get u over 2, and then you need that 2 to make it u.
Yeah, I mean,
So then if you didn't have the 1 over 2, you have to multiply it 2 and put it 2 on that.
exactly. Okay, so how do I integration something like this? And you are gonna for sure see this on AP exam. No, actually, not for sure. This is like more likely to be on BC exam than AP exam. So this is this. So now this is not possible to take it because there's no format that makes that way, right? So if it's no format, what kind of things I can do to make that become one of the format with algebra skill? You on the right track, but you cannot factor that because x squared minus 4x plus 7 is not factorable. No. But you could be on the right track, depends on if you know origin of quadratic.
It's like the middle part of the quadratic equation. Right?
You're on the right track. No, you're on the wrong track. An algebra skill that one of the very underrated skill that nobody actually able to do these days. Especially this whole class, probably none of you guys can do it. Actually, something to do. If you know how to do circle, you can know how to do that. So, what? Yep. So that is going to be x squared minus 4x is circle plus 7. Why is circle plus 7? Because what Alvin says something to do with middle term. And you're gonna take the middle term, divided by 2, and square. So that's equal to -2 squared. That's equal to 4. So I'm gonna plus 4 here, and I'm a -4 outside. Because if I plus 4 minus 4, it's gonna go back to where it was.
Should you put an equal sign between them?
What? No. Why you want the equal sign? There's no equal sign. There's just an expression. So I can factor this. So that's gonna be x minus 2 squared plus 3 integration. Now it becomes a what? What kind of format is this? Arcsine, arcsecant, arctangent. What kind of format is this? No, not sine. Arctan. U equal to x minus 2. Right? U squared equal to x minus 2 squared. A squared equal to 3. A is equal to root 3. So that's equal to 1 over root 3. Arctan of root 3 over, actually not root 3. Actually x minus 2 over root 3 plus c. And that's your final answer. Yeah. No, that's positive x. Yeah, a is root 3. Because you gotta say a squared is equal to 3. A must be root 3. Pretty hard problem. Pretty hard problem. Let's do something fun. Let's do definite integral. Get stronger. Stop complaining. There are people who says I hate this.
My offense career, bro.
Huh?
It's my up. I'll shoot it up for you.
Wow. What's the bottom top part, sorry?
E to the negative x over root 1 minus e to the 2x. Linda, wake up.
You just yawn.
I forgot the x. I'm so sorry.
Yeah, I want.
Very important piece.
Me and my dad had a fight about that last night. And he's like, Kevin, you always forget to put dx in your problems. I still don't really get why it's fucking out.
It's very important. It's very important. Because that way you can convert a dx to du. If you don't have it, you cannot take integral. Dx is a small changing of x. It's a very, very important piece. We're going to talk about it later.
So this one's just the
Nathan, you done? Huh?
No. But we can't. Alright, what are we saying then?
That's kind of weak. My goodness, I'm so sleepy.
Because it's clear. You know how to.
Everybody done? Okay, which format is this? ArcSine, Arctan, Arcsecant. Fine. Okay, first of all, what is A in this case? So A must be 1, right? What is U in this case? No.
E to the negative x.
E to the negative x. Why is it e to the negative x? Because that is u squared. So therefore, e to the negative x times e to the x is equal to e to the negative 2x. Does that make sense? No? U squared equal to e to the negative 2x. If you square root both sides, well, e to the negative x times e to the negative x, that's equal to e to the negative 2x because of the exponent rule. Is that okay? So much u is e to the negative x. What is du here? Negative e to the negative x du, right? Is that okay? So du over
No, the 2 is squared.
so du over negative e to the x, negative x, sorry, negative dx equal to du, right?
Yeah.
Actually, I just wait. Hold on a second. This is dx. I read it wrong. So I can just change this part to what?
Cancel out.
Actually, I'll cancel. I'll just cancel. I used to do that, so I'm just gonna do that. Du over negative e to the negative x equal to dx.
Yeah.
So now I'm gonna plug in a boundary. What's my boundary? E to the
Negative 1.
e to the negative ln of 4, which is what?
1/4.
It's 1/4. Thank you. E to the natural log of 2 is negative, so it's 1/2, right? So that is gonna be 1/2, or 1/4, sorry, 1/4 and 1/2. And this one is gonna be e to the negative x 1 minus u square dx equal to du over negative e to the x. So this cancel out.
Yeah, negative 1 outside.
So negative 1/2, 1/4 du over square root 1 minus u squared. So that is gonna be arcsine of what?
Negative arcsine of 1/4 plus arcsine of 1.
Negative arcsine of, well, is u over a, so it's gonna be 1/4 minus arcsine of 1/2. And there's no way for you to know arcsine of 1/2. So you can change to arcsine of 1/2 minus arcsine of 1/4. Good day. Thank you. Thank you, Luke.
I did a lot of but it was that
Question?
I was like there, I got to the I got to the part where it's like plug in the sound, and I'm like, I don't know.
Yes.
Okay.
Plugged in.
So this dx, right? Change the du over 2. So the 2 is on the bottom. But remember, the integration is du over absolute value u square root of u squared minus 9, right? So since this is 2x, this is actually a u because you gotta match this as well. So this is a u, this is a u squared. So we match this u squared. A squared is 9, right? So you needed 2x there. If you just x, then that's actually u over 2. But you need a u here. So you need this 2x to be there.
you just don't take it.
Yeah, I didn't take it out because that I needed 2x there. Okay.
Very surprising that Kevin was that able to do that.
No, he wasn't able. He got a lot of wrong, but the problem is the thing is like like the thing that he doesn't know how to do. He doesn't remember the formulas. Other than that, skill wise, he's probably skill wise he can be just good as me or better for sure. But it just he doesn't teach. He doesn't use those things for a while. If you're an engineer, you don't use those things.
I didn't know what I was like wondering which job.
He's an engineer for Lockheed.
So basically, for these equations, you don't get them in the formula. So when you do U substitution, you try and get that. You try and cancel out the numerator. Get what you need, right?
I have no idea what you just asked because whatever you ask doesn't really ring a bell with me. You gotta show me like your work and then as opposed to
Like in the middle. Oh my god. Why? Because I don't know if you're I mean, you don't now. Yeah. Like maybe the second row. I don't know. But like all the rest interact. Wake you up. No, but I feel like
Oh, I'm so sleepy. Did you say I'm emo?
Yeah, that could be a good thing, you know.
I'm emo every day.
I did the one in the first try. So I'm gonna next is like
What's it? You
so one time we do in those
Guys, if you didn't finish the redo of that, you make sure you enter that in the queue. If you redo your match, you make sure you enter match. Otherwise you're practicing something that's wrong. That's even worse. If you don't know your answer right or wrong. And we're gonna talk about a lot of those times that you have to make sure that you go in to do everything and doing everything correctly.
So it's gonna be you prime on top.
Yeah. Yeah. So you have to be one over root 4 by 6 squared.
One minus
So you I don't know where it is wrong. It's alphabetically for good and soccer.
one over x. So this is right. This is turned out into a 1.
right. Yeah. Exactly. So the y doesn't matter, but
So for this question, I like not midway through and then when I came back.
the y. So because all but like interval boundaries, like all intervals. So you want to yeah. So you have to say that so you're lower
For 2, I got negative 4. 3x 1 over 2 root x plus 2x root x.
and then you can
1 over 2x
1 over 2x.
plus 2x root x.
oh this
Because I have a different form.
for my 3 are the x 3 and then you
This is the right form, but
and I was like
much easier to take the derivative or the when you just move this one half down. No, you just lay that down. Yeah, it's 1/2. It's the same as this is 1/2 of half. Over 2 times negative half. I think that's also the same because x negative half over 2 times 1 plus x, right? And then since this is a negative, you have to bring back out. There's actually 1 over 2
You want to be what?
Oh, yeah. But that was easy. For 4, I got negative 2x over 1 plus 4. for 5, I got. So 5, no. I got negative cosine x over 5. But that's negative 1.
Yeah, no, but like, yeah, I plugged that into Debian, so it's not right. But this form is right. With the square root still?
You essentially already.
Oh, so you want to do it?
Yeah, I'm not really sure why, because that's like square root of 1 minus.
Yeah, exactly. Yeah.
But then you plug it out,
You don't get negative 1.
then it's like really good.
So I got 15 over 1 plus 9.
15 over 1.
You almost got 6 times 5 versus 2x squared over
Oh, the two's cancel.
Yeah.
No, but oh yeah. So other than that, 8x. You can factor that out, factor the 2 out.
Okay, so I know one of the question that somebody asked me was a I think this one 63. I got y minus 2 pi over 2 pi minus 4 times x minus 1. There's a product rule. How many of you guys miss the product rules?
Get better, Tyler.
What?
Yeah, I'm just kidding.
Tyler, you missed it?
Yeah, I did.
Okay, and Tyler and the Tanner, all the white people in there. Miss the product rule.
It's okay, Tyler. You do good next time.
I love that.
Brady, did you mess up the? Whoa! All the white people cannot see the product rule. It's like a. What? It's a break function.
What do you think about the 9? When you factor the 8x,
Okay, so you see it here, right?
Okay.
You can factor it out.
So what happened here is a 4x times arc cosine of x minus 1. 4x is a one function. Arc cosine of x minus 1 is another function. Ria, did you write?
I did.
Good. Ashbear, did you see it's a product rule? Good. So only white people cannot see product rule. How about black people? I'm just kidding. That's so wrong. But at least you can take a joke. I'm just trying to be.
Sean is big, I think he counts.
Sean is black.
Yeah, he's half.
Is a half black. So Sean, can you see product rule? Huh? Oh, arc cosine of 0.
Yeah.
Okay, so Tyler's asking, how do I know arc cosine of 0? That means what this is the x value. The whatever it's like, so for example, arc sine of -1/2, right? This is the y value and they ask for the radian. So this one is -π/6. Now this is the x value. X value is 0. The only time that x value is 0 is at π/2. Because that's where the x value is 0. There's no y value there. So that is π/2.
Not know if it's
Because those are restriction on the top quadrant. Yeah.
So like cosine is equal to the top two.
Yeah, top two quadrant and sine is the right two quadrant.
Oh, right there.
Yeah, right two.
For 10, I got negative 12 x times cosecant. Cosecant x squared plus 1 over x squared plus 1.
All right, so also another thing is that you guys don't check your answer through decimals. If equation tangent line, Joshua just says, equation tangent line. I forgot how to do equation tangent line. Well, equation tangent line is basically this is a coordinate of the original function, and you don't need to use the 2 pi because you are only use the x unless you have a like a function that's have to be done implicitly. It has a mixture of x and y, then you have to use both. But right now we're just gonna plug in 1 into the derivative because we're plugging 1 to find out slope at that point. So a lot of things like you guys didn't do is this. You guys did not check your answer whether that's equation tangent line or not. So pay attention. This is how you check your answers. I plug in equation tangent line. They intersect exactly that 1 point, and that's served as equation tangent line. Not only that you have to use decimals, you have to learn how to see the equation tangent line. You see this is concave down. You see your equation tangent line is always an over approximation. If you use a tangent line to approximate a value right next to there, it's above there because it's concave down. So those are the things that you guys need to learn is using decimals. Use decimals to check your answer, not photo math, not math way. Because this one, you can actually see the graph. Photo math is not going to show you the graph. Math way is not going to show you the graph. But if the more you look at the graph, the more you're understanding whether your calculation is right and what does it look like of that function. You guys got to learn to use decimals as your handicap. Not handicap, but your assistance.
Oh, you just kept it. Yeah,
I think just like boiling down is unnecessary.
so I got to there, but then I didn't send it for
It doesn't take art.
out of it as x squared plus 1.
Oh yeah, I like that.
Yeah, you can do it.
Okay, another question I want to go over is this one. This one has a chain rule. And this one doesn't have product rule. It's question, I don't know which one is it.
Number 10.
Yeah, for this particular case, why this absolute value is not needed though. I don't have to put absolute value because x squared plus 1 is always positive. So think about x squared plus 1 is like this graph like this. So is this absolute value needed? No, it doesn't need it. It can be leave it alone. Same things like e to the 2x from yesterday's question. This doesn't have to need an absolute value. So you didn't put absolute value. I'm okay with it. I'm okay with it in this situation. Now, if you have says, I don't know, x, then you need to put absolute value because x can be negative, right? So that's a point that you have to understand. Absolute value when you need it and when you don't need it. Now, you're going to take a chain rule first and then take a derivative. And derivative of cosecant is going to be negative 2x over u times u squared minus 1. And I did that one. Also, yesterday at tutoring, I messed up this one by accident, but this one is going to be negative 1 over x squared plus 1, tangent inverse of 1 over x. I think somebody missed a negative sign somewhere. I saw when I was walking around. Okay, any other question you want me to go over? You can check your answer on Mathway. You can check your answer on things that's not about graphing. Like it's just a mechanical where you just want to take integrate or derivative or something. I mean, check out the Mathway. It's fine. But like equation tangent line, I really think about you should use decimals.
pi over 8 is equal to negative root 2 over 2.
And please simplify this correctly. Some people doubt they can split like this. They cannot split like this. That's just not mathematically correct. If you did that, you did it wrong.
No, y minus pi 4.
I have seen that today too.
So 61. 62. Yeah, that's all. 4 root 2 times root pi over 2 minus pi squared minus 2, right? I'm pretty sure you can simplify this.
What was your slope again?
4 over root 2 times root pi squared minus 2.
Bro, every single time.
What was your slope before you?
I try to figure it
Slope over my derivative?
Keep the top. Chase
4 over 4x times root 16
Or
x
just do
squared
it.
minus 1.
I just like, I can do it. Like, I can think about it. I just like flip twice.
Did you put in your pi over 4 by chance instead of your square root 2 over 4?
Yeah.
All right. Next question. Any questions I need? I'm going to cover today's stuff. Okay, let's cover today's stuff then. Today's stuff is this. So it's really like reverse of what we learned yesterday. So du over square root of a squared minus u squared is equal to arc sine of u over a plus c. This is the first one. The second one is du over a squared plus u squared is equal to 1 over a arc 10 of u over a plus c. That's the second one. The third one is going to be du over u times square root u squared minus a squared is equal to 1 over a arc secant of absolute value u over a plus c. So there are 3. Now the index card material only in the first 2. On AP exam, they only ask you the first 2. They're not gonna ask you arc secant. I will not ask you arc secant on my test, even though I'm a pretty hard teacher, but I don't even remember arc secant myself. So I won't ask you to remember it because the time that I use it almost like once out of blue moon. So I'm not gonna ask you to actually memorize that one. But we're gonna practice that one in the classwork. We're not gonna practice that one in the actual test. So index card, if you want to make index card help you memorize all the formulas, the derivative sign, derivative tangent, and the integration of sign and arcsine and arctangent, those are very, very important materials. So you have to know that. With that being said, let's try one, see if you guys can handle it. So dx, I'm gonna teach you how to do it correctly, okay? Now, sometimes people says, nah, I don't need to listen to you. I know how to do this. And yeah, more likely you can figure out how to do integration of dx over root 4 minus x squared in 10 seconds. But I'm going to try to teach you to do it right way. And you might not pay attention to me, but oh well. So in this case, this looks like which kind of format? Sine. Okay, so I'm going to write down kind of thing. A squared is equal to 4. A is equal to 2. U squared is equal to x squared. U is equal to x. Du equal to dx. So obviously that's integration of du over square root a squared minus u squared. So that's going to be arc sine of u over a, so be x over 2 plus c, and I'm done. And realize that the first one doesn't have 1 over a in the front, but arc10 and arcsecant has a 1 over a in the front. Don't ask me why, I don't know why. I never bothered to look it up, but I just you know, maybe I should look it up, but I'm too lazy. So, but then I'm gonna give you this question, ask you to do it yourself, and I can. Last period I.
Oh wow. I'm kidding.
Does anybody see a black book back here? It fits around here. Don't see it here. Is that Mirella back?
No, this is Vegas.
Huh?
This is Vegas.
No, I don't see it. Is that hers? No? No, I don't see it. He's a football coach?
This is like a game.
No, she was carrying backpack.
She's leaving. I don't know. All right. So I want you to take the integration of this one, and I'm gonna say it's probably no one will get it right. It's a very easy question, but a lot of people kind of say. I'm not gonna say like just you. Like I remember when I was a student, I got it wrong as well. So I'm hoping some of you guys are smarter than me. All right. How many people are comfortable with the answer? Want to share with me? Anderson? Yeah. No. Just read it to me.
1/3 times 1 over root 2 arctan 3x over root 2. Let's see.
Wait, say that again.
Like parentheses and 1 over root 2 arctangent 3x over root 2. Let's see.
Jamie, what'd you get?
Same thing.
Ria, what'd you get?
I didn't get the 1/3, but
Okay, so I'm glad those two people got it right. If you got the same answers, then you got it right. How many of you guys got it right? Oh, Elise, nice. People don't pay attention to the small details. I write it right here that you guys didn't pay attention because a squared is equal to 2. A is equal to square root 2. U squared is equal to 3x squared, so it's 9x squared, sorry. 9x squared, and the u must be equal to 3x. But you gotta also including du. And this is what people usually don't pay attention to details. And I'm glad there's 2 or 3 students got it right. Because this one is going to be right as a squared plus u squared. And this is going to be du 1 over third. And this 1 over third in the front matter. Because that means because 1/3 and it's arc10. So it'll be root 2 times arc10 of 3x over root 2 plus c. And this is what people miss up this part because this part. And so you have to be very cautious when you're doing things like that. Okay, and you have to match up a lot of things. So even though like sometimes people don't see that I write the steps, that I just want to show you that, you know, I want to make sure everything is substituted correctly. So yeah, Anderson, good job. And also Wesley, and also Jamie. So this is another question. This is actually a pretty interesting question because it's kind of different.
Like, I know you got 1 over 3, but how do you get root 2 as well?
It's 1 over a. Do you see the equation is 1 over a here? Yeah. And maybe can you write down? This is a. Only the arc10 and arcsecant has 1 over a. Arcsine doesn't have 1 over a. So so sleepy. So I hear a squared equal to 9, a equal to 3, u 4x squared, u is equal to what? 2x, du equal to 2 dx, right? Du over 2 is equal to dx. So I'm going to change everything in terms of du. So this is going to be du, but I'm going to do it like halfway because I need to make sure something. I only changed the dx to du over 2 here. I only do that. I didn't do anything extra. Now I am going to substitute in terms of u. So du over, do you see this 2x is actually u? So I just changed the format to the arcsecant. So remember it's 1 over a arcsecant of u over a and that is the only thing. It's not 1 over 6. Some of you guys got 1 over 6 because that the 2x is actually u. So like something like you guys are very rushed into do things, but if you gotta think about it, just be patient and see like which one is matching up. and things like that. Yes.
Like in the original.
What?
Like you said this.
This x?
Yeah, you changed it.
Because remember this dx, right? Change the du over 2, right? So now that you have enough to become a u, because this is actually x, there's half of u, but you need to have a u here. So I actually didn't take it a 2 outside, because usually I would take a 2 outside there. But since this is an x, it's not u, because u is equal to 2x. So you need a 2 there. So I just changed that u is equal to 2x there. So I'll leave the 2 inside. Yes. A is always constant, yes. Yes.
So then the 2x have to be out.
Yes, they are absolute value. You're right. Absolutely. Thank you. Appreciate that.
Did you change the x to
If you drop the du, you have a d over 2, if you drop the 2, then it becomes u 2x, then you can flip it for you.
So I did this du over 2, right? This is the when I changed that. And this is gonna be, I haven't complete substitute yet. This is a u squared, this is a, this is u. So now some of the harder question will be like this. Now this is not even the hardest one, but on the AP exam they go as far as this. They don't go further than this. There's actually even harder than this. But right here is the dx over x squared minus 4x plus 7. Now, how do I integrate this? Okay, how do I integrate this? Now, obviously, this is not in terms of arcsine, arctan, or arcsecant, because it doesn't seem like I have 2 terms. And even with arcsecant, there's 3 terms, there's a square root. There's no square root here. So there's probably some type of obstacle. Now, is anything I can change the bottom into in terms of other ways? So when you take SAT, when you have standard form of a circle, what are you supposed to do? Complete a square. Do you guys know how to complete a square here? Okay. Well, if I complete a square, and gotta make sure you do it right, x squared minus 4x, and I'll keep a parenthesis and keep some room plus 7 like this. And we have the space here, and we have space here. We gotta fill in that space. We gotta fill in the blank. Complete a square, take the middle term, which is -4, always divided by 2, and square. Do you remember doing that on SAT? Sean, quit your job. Stop being an idiot. -4. Get your SAT score up, and then you can get your job back. Because you make a lot more money that way. His logic is to watch free movies.
It's worth it though, so you get unlimited popcorn too.
Unlimited popcorn.
Exactly. Wait, why is it -4?
Because you want to go back to before. You want to add 4 and subtract 4. Like it. You eat and you gain like 4 pounds and you say, yeah, no, I'm too fat. I need to go back to before. So you have to subtract 4 to balance. So you're still the same as before. You're not changing the equation. You adding 1, you subtracting 1. They're the same thing. That's why the complete the square works. Now, for sometimes depends on different side of the equation. If you're adding one number, you have to add the other number on the other side. That's because on the other side. But this is the case, is on the same side of the equation. You basically, I decide to say, oh shit, I'm too fat. I just gained 5 pounds, and I can say, okay, I'm gonna lose 5 pounds to go back to before, and that's the way it is. What?
It's on the same side. So
Yeah, on the same side. Yeah, so you had to gain and lose. So in a way, that's gonna be x minus 2 square plus 3. Why is that good? Because this is in the format of what? Arcsine, arctan, arcsecant. What is it? It's arctan. So it'll be arc 10 of x minus 2 over 3. Wait, root 3, right? Sorry, I must make a mistake. 1 by root 3 plus c. So why is root 3? Because u square is equal to x minus 2 square. U is equal to x minus 2. Du equal to dx, so there's no dx issue. A squared equal to 3. A is equal to root 3. And now I gotta just plug in, and boom, I'm done. So that's complete the square. So you're gonna have a couple homework questions that you had to complete the square. Hopefully you know it's gonna help you on SAT. Now you can use decimals, so I don't know if you still need to know how to complete the square. Decimal really change your SAT so much easier.
For the, how would you know which one's A and which is U?
A is always a constant. U is always a variable. Very good question. I think Elise asked that earlier too. So, all right. So I'm gonna ask you a question, but this is gonna be a definite integral. So I am gonna give you questions because we never give you a definite integral before. So we're gonna give you a definite integral. Jordan, are you okay?
Yeah.
You're not, Cal?
Huh?
You're sleeping?
No, I'm good.
Finish?
Figure let's go to Hewlett.
Gotta think. What time we get off here?
Yeah, like, what is it? You can cancel it. No? Okay. No, I just wrote it down. No, it's not this one. Wait, let's. Oh, how do you fix that? Cancel this. So this one. I don't know. Oh, yeah. I just, yeah.
Okay, so this is a review a little bit. U equal to, what's U equal to?
E1 minus E2. Oh, you just know with you?
Oh, what? Okay, let's start with it. What is U square? What is U square? E to the negative 2x? Good. Now, what's U though?
E to the negative.
E to the negative x. Why is that? Because e to the negative x times e to the negative x is what? It's the exponent rule, right? A to the m times a to the n, same base, a to the m plus n. So this is e to the negative 2x. Does that make sense?
Oh.
So a squared is equal to 1. A is equal to 1. So, is that okay? Now I'm gonna do du as well. What is du? Dx. Don't forget dx. A lot of you guys forget dx. Because du over negative e to the negative x is equal to dx. Now what else I have to do? Change your bound and just do it in terms of u, right? So e to the negative ln of 4. Wait, can e and ln cancel out at this moment? No, so that'd be e to the ln of 4 to the negative 1. Now they can cancel, that's equal to 1 over 4. Does that make sense? E to the negative ln of 2, that's equal to e to the ln of 2 to the negative 1. This cancel out, 2 to the negative 1 is 1 over 2. So therefore, I have upper bound and lower bound. And root a squared minus u squared. And du times negative e to the negative x times e to the negative x. This will cancel out. And the negative sign in the front. 1 over root a squared minus u squared between 1/2 and 1/4. Does that make sense? And that's equal to negative arc sine of 1/4 minus arc sine of 1/2. So that is going to be arc sine of 1/2 minus arc sine of 1/2, 1/4. And this is equal to final answer. And I got this answer. I'm happy with it because the rest of them I can use calculator.
Since your lower bound is 1/2.
Wait, hold on a second. Yeah, 1/4. Yeah, that doesn't matter because I just follow the fundamental theorem of calculus, which is f of b minus f of a. Yeah.
U over A, but in this case it's A is 1, it doesn't matter. Like you just
Yeah, so it's so let me write down here. It's gonna be negative arc sine of u, which is u over a, right? A is 1, so and doesn't matter from 1/4, 1/2. You can try one of the homework question. This one actually get a really nice answer. 1/6/0 over 1 minus 9x squared dx. This is actually one of the homework questions. I think this one has a nice answer if I remember correctly. Because arc sine of 1/2. What's arc sine of 1/2? That's pi over 6, right? You can say pi over 6, but the problem arc sine of 1/4 is not able to define. So you can say arc sine of 1/4 like that.
I don't really know.
You don't know how to find arc sine of 1/2? That means when y value is 1/2, what's my radian? So look up a unit circle when its arc sine is 1/2, which is sine inverse of 1/2.
how do you know this is U squared? And not when it's the e to the negative 2x? Because with this formula, like this is U squared. So it must be.
Hey, Mr. Yin, when do you like put the u back into the integral after you change the bounds? Why did you put e to u instead of just u?
What did you say? I don't understand what you're saying.
That's red part. Why did you put e to the negative u instead of just like two? It's u stuff.
It's u over a, right? So u over 1. And this is already in terms of u, so I just plug in 1/4 and 1/2. Here?
The step below it.
Oh, the step before, I cancel out e to the negative x. So I put a negative sign outside. Oh, sleepy. Yeah, the answer of this one's really nice.
Wait. So it's e over 1. It's just e. over one. Oh, yours is.
The Android got 5 or 6.
You need it?
No, I know you did it, but I need you to understand it.
I mean, I was taught through it, and then some, like half of them I did on my own. But if I keep it, I'll look it over.
I'll let you keep it. I know I saw it. Grace? Are you doing okay today?
I'm doing swell.
You sure?
Better than yesterday and the day before. The day before that.
Okay. But I don't know if you. I wasn't trying to attack you.
I know. I'm sorry for like breaking down. I'm an emotional person. But
I know, I can see, and I'm okay whether you let your emotion out, but I just so you know is, I never care people not doing well something. I just want you guys to always bounce back, and just say, hey, that's how much I understand. I understand 15, 20, 30% or whatever, and let's start going over there and let's start understand more. And I think like Sydney, she didn't do it well, just like you, and but sometimes positive attitude, just have the positive outlook, have the growth mindset, just trying to keep on getting better. That is the key. Like I said, you're gonna learn more about life than math here, so just hopefully you keep on bounce back.
Alright, well, I gotta go.
Okay.
Thank you, Mr. Yen.
All right. Take it easy. That's a fake smile.
Fake or
Fake.
I'm so unhappy to be here.
You're so unhappy to be here. Unhappy.
I'm wearing 3 hoodies right now.
Why are you doing that?
Because I left 2 of them in here yesterday after school, and I was already wearing one. Because I had one in my backpack that I had forgotten.
You know, I keep on throwing away people's sweaters.
That's why I came here first thing in the morning, so that I didn't have.
I take it that means sweater as a mop floor one time.
Dude, I used that shirt to clean up my water spill over there one time. It was sitting there for a really long time.
Okay, what time will class end?
I don't know.
Mm-hmm.
11:02.
11 what?
11:02.
11:02. Okay, 11:02.
I'm like, hey. But yeah, I finished the homework.
It's supposed to finish your homework.
Huh?
11:02 I get off. Andy says it's fixed. 在那个 back gate 那边等我好，就跳过去就好。It's hot in here.
You see that machine?
Yeah, Aiden, be nice.
You wanna know what the reaction is if he can't pull this over? Hi, Corson. We figured it out. We figured it out.
Like,
Oh,
I start negative. The last two. Like, there's like the 4x and then a 3x.
Yesterday, it's not. I'm getting more
Catherine's back. Are you okay? Were you sick?
Yes, he still goes here. His dad's like down here. Really? Yeah, life. Oh. He's still here. So last two problems.
the first 63rd, I'm okay with.
So 63 is
Four?
everything else I finished.
To be honest, don't trust me with what I say. I might be wrong.
Simon!
Hi, Simon.
If you want good help, that's been good.
Nobody else in the table will show up.
Okay. Did you
Chase and Tony. Where's Chase and Tony? And Min. Oh, Chase, Tony, Min. Chase, Tony, and Min.
Okay.
Chase is not here. Oh, Chase.
So this is after I take the derivative of
Chase!
But you got it.
Chase is in the house. Party could have started. Chase in the house.
So what I do? So is it like?
As it Chase in the house, party can get started.
Okay.
So that's right.
Party started.
But you have to do the derivative of 4x times arc cos.
Oh, wait. So
Because it's product rule.
It's product.
So if you take the derivative of this, which is 4 times just x minus 1, and then this 4x times the
Yeah.
Yes.
D left, left Z, right?
Yes.
It doesn't matter which way you do it. High do low, do high, high do low.
Lodi, hi, no.
Like my little mound here that I have now.
Don't leave it here. I'll
go to
Josh.
I do not want to leave it here.
Ethan, you should leave it here.
I don't know. I'm not gonna throw away 3 hoodies. These are like almost all of. This is like every hoodie that I currently wear right now.
But Ethan, what did you get for
Plus 4 times x
Well,
minus
yes, I
1.
have a shirt. People are like surprised that I'm wearing a shirt.
It's like this.
Wait, you wore all three of those? What? Three hoodies.
I wasn't. 4th and 5th are like where I get the.
Because it's
where
art.
I get the-
It's arc cosine.
Like that's what I was wearing that in second period, Raj.
It's for the derivative of 4x.
I thought it-
times arc cosine.
It's growing. I can't wait for tomorrow to come in.
This is this the derivative? No, okay. So, sorry. This is left. This is right. Left be right. Plus right be left.
Low be high, high be low.
So I'm doing left derivative times right, left derivative right, plus.
Alright.
This whole thing, the entirety of arc cosine is right. Also, you
Where's Matt?
Okay.
Wait.
Yeah, though. So is it?
all it really does is steal my bits.
Oh yeah,